Welcome all. In today's session, we will be seeing shortcuts on pipes and cistern. So let us begin the chapter with the small introduction. So what do you mean by pipes? Pipes are nothing but they carry water. Okay, there are two types, that is inlet pipe and outlet pipe. So inlet pipe carries water inside the tank, okay, and outlet pipe takes water away, or it removes water, takes out or removes water from the tank. Okay, so what do you mean by cistern? Cistern is nothing but a tank, or it is a large container, okay, which will contain or which will hold water. Okay, it is a large container or a tank like thing which will hold water. Okay, so if this is a tank, okay, and this is one pipe here and there is one more pipe here. So this pipe we call it as inlet pipe. Okay, this pipe, since it is carrying water inside the tank, it is taking water inside the tank, it is known as inlet pipe, and this pipe will take water out of the tank. Okay, hence we call it as outlet pipe, and this tank is nothing but the cistern. Okay, it is nothing but the cistern, or it is tank, or a container, a large container. Okay, so in this chapter we will see some problems, some basic problems. Okay, some basic problems we will see. Then we will see some problems regarding efficiency. Okay, efficiency of the pipes. Okay, there will be comparison between the efficiency of pipe. For example, if pipe A is more efficient than B, or B is 3 times more efficient than A. Okay, such problems, that is where efficiency of the pipes is concerned. And third type problems we will see where the pipes are working alternately. Okay, alternatively. So if pipe A is working first minute, then pipe B will be working second minute. Then this goes on continuing alternately, A, B like this. Okay, so alternatively working problems we will see in third part. So these are the three parts in which I have divided the problems, and we will discuss each problem detailedly, and we will see the shortcuts regarding those. Okay, so let us begin with our first problem. Two pipes A and B can fill a tank in 10 hours and 12 hours respectively. Okay, there are two pipes A and B. A can fill the tank in 10 hours and B can fill it in 12 hours. While a third pipe, there is one more pipe, third pipe, and which can empty the full tank. Okay, the third pipe will empty the full tank in 30 hours. So if all the three pipes operate simultaneously, if all three are operating simultaneously, simultaneously means at a time. Okay, simultaneously means at a time, same time. In how much time the tank will be filled? So if all three are operating simultaneously, so in what time the tank will be filled? So these pipes and cistern problems also I will use the same method as I used in time and work. Okay, the same method what we did in time and work, the short trick, same type we will solve pipes and cistern problems also. So you can say that pipes and cistern is nothing but the application of time and work. Okay, time and work application is nothing but pipes and cistern problems. Okay, it is one of the application of time and work concept. Okay, so the same concept what we did discussed in time and work, same thing or same method we will be using to solve pipes and cistern problems also. Okay, so the first problem. Now we know that pipe A will fill the tank in 10 hours. So when there is filling of the tank, I will denote it by plus sign. Okay, and if the tank is if the pipe is emptying the tank, then I will denote it with negative sign. Okay, then pipe B will fill the tank in 12 hours, and there is one more pipe, third pipe. So let me name it the third pipe as C. Okay, so if the third pipe is C, it is emptying the full tank in 30 hours. So to denote emptying, I will denote it by negative sign. So pipe A will fill the tank in 10 hours, B will fill in 12 hours, and C will empty it in 30 hours. Now all three are operating at a time. Okay, when all three are operating at a time, so in how much time the tank will be filled? See, these two are filling the tank, but this is emptying the tank. So all three are operating together. Okay, so to solve such problems, first we will take LCM of these. Okay, the same thing what we did in time and work. So whatever LCM we will get, that will give us the total capacity of the tank. Okay, total capacity of the tank. Whatever LCM we will get, that is nothing but it is the total capacity of the tank. So 10, 12 and 30. What is the LCM of this? 30 ones are 30. 30 is not divisible by 12. So next 32 is 60. So 60 is divisible by 12 also and 10 also. So 60 is the least common multiple between 10, 12 and 30. So it is 30 is the LCM. 60 is the LCM. So 60 units. So what is the capacity of the tank? It is 60 units. Okay. So now we will see the efficiency of each pipe. Okay. So if a pipe A fills 60 units, okay, in 10 hours, okay, because the tank capacity is 60 units, so it is taking 10 hours to fill the tank. So if A can fill 60 units in 10 hours, then in 1 hour, how much it will fill? It is given by 60 divided by 10, which is equal to 6 hours. 6 units per hour. It is 6. It can fill 6 units per hour. Similarly for B, if B can fill 60 units in 12 hours, then in 1 hour how much it will fill? That is 60 divided by 12, 1s are 5s are. So it can fill 5 units per hour. Now pipe C, it is not filling, it is emptying, isn't it? So it can empty 60 units in 30 hours. So in 1 hour how much it can empty? It can empty 60 divided by 30, 1s are 2s are. So it can empty 2 units per hour. Okay. Now all three are operating simultaneously, they are saying. So that is A plus B plus C, all three are operating simultaneously. So A can fill 6 units in 1 hour and B can, so filling I will indicate with plus sign. So B can fill it in 5 hours and 5 units in 1 hour, and C can empty 2 units in 1 hour. So it is plus 6, plus 5 and minus 2. So all three when they are operating, so what is the result? Plus 6 plus 5 is plus 11 and minus 2 is plus 9. So when all three are operating together, we got plus 9, means what? It is when all three are operating together, they will fill 9 units, even though this is removing water, but these two are filling water, isn't it? So even if this is a C pipe is removing, we got plus 9, that means 9 units per hour is filled, okay, when all three are operating together. So if 9 units per hour they are filling, then to fill 60 units, how much time is required? So 9 units they will fill when all three are operating. The tank will fill 9 units in 1 hour. So 60 units in how many hours? Because 60 is the total capacity of the tank. So therefore 60 divided by 9. So 9 ones are, or you can write it as 9 6 are 54 and 2 by 3 will remain. Okay. So therefore the whole tank is filled in 6 2 by 3 hours. When all three are operating together, the total time taken by the pipe to fill the tank is 6 2 by 3 hours. Okay. So next problem. A pipe can fill a tank in 12 minutes and another pipe can fill it in 15 minutes. But a third pipe can empty the tank in 6 minutes. Okay. The first two pipes are kept open for the first 5 minutes and then the third pipe is also opened. In how much time the tank will be completely empty after opening the third pipe? Okay. So what they are saying, there is one pipe, let me name it as A. The pipe A will fill a tank in 12 minutes. Then second pipe will name it as B. So another pipe will fill the tank, same tank, in 15 minutes. But there is a third pipe C which will empty the tank in 6 minutes. Okay. So these both will fill, this will empty. Now first step is what? Always take LCM. That will give us the total capacity of the tank. Okay, the LCM of these three. So what is the LCM of 12, 15 and 6? So 15 is the greater number. So see the multiples of 15. 15 ones are 15. It is not divisible by 12 also, 6 also. Next 15 twos are 30. 30 is divisible by 6 but not by 12. Next 15 3s is 45. 45 is not divisible by 12 also, 6 also. Now 15 4s are 60. Yes, 60 is divisible by 12 also and 6 also. So therefore 60 is the LCM. So 60 units is the total capacity of the tank. Okay, this is the LCM. Now 60 units of tank is filled by A in 12 minutes. So in 1 minute how much it will fill? That will give us the efficiency. So first thing we should first we have to calculate, see the LCM. The second step is always find out the efficiency. So A will fill how much in 1 minute? 60 by 12, which is equal to 5. So A will fill 5 units in 1 minute. Okay, 5 units in 1 minute. Then B will fill 60 units in 15 minutes. So in 1 minute how much it will fill? 60 by 15, which is equal to 4 units per minute. Then C can empty 60 units in 6 minutes. So in 1 minute how much it will empty? 60 by 6, which is equal to 10 units per minute it will empty. Okay, these are filling, this is emptying. Now they are saying if first two pipes are kept open for the first 5 minutes. Okay, for first 5 minutes A and B are kept open. So that means A and B are filling the tank. So in first 5 minutes how much of the tank is filled? So let us see. Now A and B are together, how much they are filling? A will fill 5 units in 1 minute and B is filling 4 units in 1 minute. So total 9 units they are filling in 1 minute. Okay, in 1 minute. So for 5 minutes how much they will fill? So 9 into 5, which is equal to 45 units. So 45 units of the tank is filled in first 5 minutes. Okay, 45 units is filled in first 5 minutes. Okay, then after 5 minutes the third pipe is also opened. Now third pipe will empty the tank. So now A, B and C all are opened after 5 minutes. Okay, then when all are opened after 5 minutes, then what will be the resultant? So A will fill the tank, so we'll indicate it with plus 5. A will fill the tank 5 units in 1 minute and B will fill 4 units in 1 minute, but C will empty the tank, that is how much? 10 units. So emptying will indicate with minus 10 units in 1 minute. So totally it is plus 5 plus 4 is plus 9 and minus 10. So it is minus 1. So totally what is the resulting thing happening? That is 1 unit per minute the tank is becoming empty. That is, the pipe C will empty 1 unit in 1 minute. So if C takes 1 unit, okay, if C takes 1 minute to, in 1 minute if C can empty 1 unit, then in how many minutes the whole tank is emptying, they are saying. So whole tank is how much? 60 units, isn't 60 units is the whole tank. But is 60 units completely filled after 5 minutes? No, the tank is only 45 units filled, isn't it? So what is the question? In how much tank the tank will be completely empty after the opening of third pipe? So the tank is not filled completely. The capacity of the tank is 60 units, but the 60 units is not completely filled. How much it is filled? Only 45 units is filled by A and B in 5 minutes. So after 5 minutes C is opened. So after once all three are operating, what is happening? The resulting thing, the 1 unit per minute is emptying. Okay, so C will have to empty how much? It has to empty 45 units, not 60 units, because only 45 units of the total capacity of the tank is filled. Okay, so if in 1 minute 1 unit of water C is emptying, so in how many minutes it will empty 45 units? In 45 minutes. Okay, so the third pipe, that is C, will take 45 minutes to empty the tank completely. Okay, so the next problem, 2 pipes A and B can fill a tank in 80 minutes and 60 minutes respectively. There is an outlet C. If all the 3 pipes are opened together, the tank takes 40 minutes to fill completely. So how much time will C take to empty the full tank? Okay, so as the data is given, we will go on analyzing the data step by step and we'll go on solving. Okay, first thing, 2 pipes A and B can fill a tank in 80 minutes and 60 minutes. Okay, there are 2 pipes A and B. A will fill the tank in 80 minutes, so filling will indicate with plus, and B will fill in 60 minutes. And there is also an outlet C. There is one more pipe, that is outlet pipe C. If all the 3 outlet pipe, means C will empty the tank. Okay, if A and B are inlet pipes and C is outlet. Outlet means it will take water away from or out of the tank. If all the 3 pipes are opened together, the tank takes 40 minutes to fill completely. Okay, they are saying if all 3 are operating together, that is A plus B plus C. Okay, there is one more pipe C which is an outlet pipe. Okay, so if all 3 are operating together, it takes 40 minutes to fill the tank. So this is also plus. Now in how much time C takes to empty the full tank? Okay, what is the time taken by C, okay, to empty the tank, they are asking. So first thing is, if I take the LCM of all these 3, so the LCM will nothing but it gives us the total capacity of the tank. So 80, 60 and 40 LCM. So greater number is 80. So see the multiples of 80. 80 ones are 80. 80 is divisible by 40 but not by 60. 80 twos are is 160. 160 is divisible by 40 again but not by 60. Now 83 is 240. Yes, 240 is divisible by 60 also and 40 also. So 240 is the LCM. Okay. So the capacity of the tank is how much? 240 units. Okay. Next step is see the efficiency of each pipe. Okay. Next step we have to see efficiency. Now we know that pipe A will fill 240 units in 80 minutes. So in 1 unit how much it will fill? 240 divided by 80, which is equal to 3 units per minute. Okay. Pipe A will fill 3 units per minute. We will indicate with plus. Next, pipe B, it will fill 240 units in 60 minutes. So in 1 minute how much it will fill? 240 divided by 60, which is equal to 4 units per minute. Next, A, B and C together will take 40 minutes to fill 240 units. So in 1 unit how much, in 1 minute how much they will fill? Okay, so A, B and C together. So how much they are taking? 240 units in 40 minutes. So in 1 minute they will fill 6 units per minute. Okay. Now we know that A, B and C are operating together. Now they will, when they are operating together, they will fill 60 units, 6 units in 1 minute. When all three are operating together, they will fill a tank of 6 units per minute. But we know that A will fill 3 units per minute and B will fill 7 units per minute. Sorry, 4 units per minute. So totally A and B together they have to fill 7 units per minute, but only 6 units per minute is filling. Why is that? Because C is removing some water. So 3 plus 4 is 7 minus 1. Okay, if there is minus 1, we will get 6 units per minute. So that means C is emptying 1 unit per minute. C is emptying 1 unit per minute. Okay. Now, how much time will C take to empty the full tank, they are saying. So if C can empty 1 unit in 1 minute, so to empty 240 units, they are asking to empty the full tank. Okay, to empty the full tank, that is 240 units, how many minutes C will take? Okay, so it is 240 into 1, that is nothing but 240 minutes. Okay, C will take 240 minutes to empty the tank. But the options are in hours, so we have to convert this in hours. Okay, so 240 hours to minutes to convert it into hours divided by 60. So it is 1s 4s, which is equal to 4 hours. Okay, so C will take 4 hours to empty the full tank. Option D is the answer. Okay, so from this, what we got from this data, we got in how much C will empty how many units in 1 minute. Okay, that we got it from this data. Okay, so next problem. Two pipes A and B can fill a cistern in 15 hours and 10 hours respectively. A tap C can empty the full cistern in 30 hours. All the 3 taps were open for 3 hours. Then tap C was closed. How many hours more would it take for cistern to be filled? Okay. Now, there are 2 pipes A and B. A can fill a cistern in 15 hours and B can fill a cistern in 10 hours. A tap C C can empty the full cistern. Okay, there is a C tap which will empty the full cistern in 30 hours. So emptying will denote it by negative. So all the 3 taps are open for 3 hours. Okay, so for 3 hours all 3 are open. Then what? After 3 hours tap C is closed. So after that, how many hours more it will take for the cistern to be filled? The first step is take LCM. This will give us the total capacity of the tank. So LCM of 15, 10 and 30 is 30 units because greater number is 30. So 30 ones is 30, 30 is divisible by 10 also and 15 also. So 30 is the LCM. So 30 units is the capacity of the tank. Next we will see the efficiency. So efficiency of A. A can fill 30 units in 15 hours. So in 1 hour how much it will fill? 30 divided by 15 which is equal to 2 units per hour. So A can fill 2 units per hour. So B can fill how much? 30 by 10 which is equal to 3 units per hour. Then C can empty 30 units in 30 hours. So in 1 hour how much it can empty? 30 divided by 30 which is equal to 1 unit per hour C can empty. So for first 3 hours all 3 are open. So when all 3 are open, what is the resultant thing happening? Whether it is filling or emptying, we'll see. So A can fill the tank in 2 units per hour. B can fill the tank, that is 3 units per hour. But C can empty 1 unit per hour. So it is plus 2 plus 3 minus 1 which is equal to plus 5 minus 1 will be plus 4. So even after C is open, filling of the tank is happening. That is how much? 4 units per hour. Okay, that is when all 3 are operating, when A, B and C all are operating, 4 units of tank is filled in 1 hour. Okay, then in 3 hours how much it is filled? Because for first 3 hours all 3 are opening. So for 3 hours how much tank they are filling? So it is 3 into 4 which is equal to 12 units. So in first 3 hours 12 units of the tank is filled. So remaining is how much? Remaining is how much? 30 units minus 12 which is equal to 18 units. So after 3 hours pipe C is closed. Now after that till then 12 units was filled. Now 18 units is still remaining and this 18 units has to be filled by A and B now because now C is closed. So if A will fill 2 units in 1 hour and B will fill 3 units in 1 hour. So totally they are filling 5 units in 1 hour. So remaining is how much? 18 units. So 18 units in how many hours they will fill? Okay. So that is 18 divided by 5 which is equal to 3 by 5 hours. Okay. But in options answer is in hours and minutes. So we have to convert 3 by 5 hours into minutes. So 3 is complete hours. So 3 by 5 is how much minutes we will see. So 3 hours. So 3 by 5 to convert it into minutes, multiply it with 16, 60. So 5 ones are 5, 12 are 12 threes are 36, isn't it? So therefore the total time take, so that how much more time A, B will take? They will take 3 hours 36 minutes. Okay, A and B will take 3 hours 36 minutes more to fill the remaining 18 units. Okay, so option C is the answer. Next problem. Pipe A, B and C together fill the tank in 8 hours. Okay, 8 hours. pipe B and C, A, B and C together will fill it in 8 hours. B and C will fill it in 10 hours and A and C will fill it in 12 hours. So, in how many hours A and B will fill the tank? Okay. Now, A, B and C will fill a tank in 8 hours. Then, B and C will fill it in 10 hours and A and C will fill it in 12 hours. So, A and B will fill the tank in how many hours they are asking. Okay. So, first take the LCM of all these three, which will give us total capacity. So, 8, 10 and 12 LCM is 120. Okay, 120 is the LCM. So, the total capacity of the tank is how much? 120 units. So, next step is to see the efficiency. So, efficiency of A, B and C. A, B and C are filling 120 units in 8 hours. So, in 1 hour how much they will fill? 120 divided by 8, which will give us 15 units per hour. Okay, they are filling 15 units per hour. Then B and C are filling 120 units in 10 hours. So, in 1 hour how much they will fill? They will fill 12 units in 1 hour. Then A and C. A and C will fill 120 units in 12 hours. So, in 1 hour how much they are filling? They are filling 10 units in 1 hour. Okay. Now, we know that A, B and C together will fill 15 units in 1 hour. Okay. And we know that B and C will fill 12 units in 1 hour. So, in how much A will fill? How much A will take? A plus 12 is equal to 15. Therefore, A is equal to 3 units per hour. Okay, A will fill 3 units per hour. So, A's we got. Now, we have to find out B's. Okay. Now, we know that A, B and C together will fill 15 units in 1 hour, but A and C, okay, A and C will fill 10 units in 1 hour. So, B will fill how much? So, it is B plus 10 is equal to 15. Therefore, B is equal to 15 minus 10, which is equal to 5 units in 1 hour. So, B will fill 5 units in 1 hour. So, therefore, A and B together how much they will fill? 3 plus 5, which is equal to 8 units in 1 hour. Okay, A and B together will fill 8 units in 1 hour. So, together to fill 120 units, A and B will take how much time? Okay, so therefore, it is 120 divided by 8, which is equal to 15 hours. Okay, so A and B will take 15 hours to fill the tank. So, option A is the answer. So, next problem. Two pipes can fill a tank in 6 hours and 8 hours respectively, and another pipe can empty it in 12 hours. If these pipes are opened at 7 am, 8 am and 9 am, so at what time tank will be filled? Okay. So, two pipes can fill a tank. So, let us take name them as A and B. Okay. A pipe A will fill a tank in 6 hours. Okay. And B will fill it in 8 hours. And another pipe can empty. So, we will name it as C. So, C will empty it in 12 hours. Okay. So, it is minus. So, if these pipes are opened at 7 am, 8 am and 9 am respectively, they are saying. Okay. That means A is opened at 7 am, B at 8 am and C at 9 am. So at what time the tank will be filled? So at what time that full tank will be filled? So first thing, take LCM of all these three, which will give us total capacity. So 6, 8 and 12, LCM is 24. So 24 units is the LCM and it is the total capacity of the tank. So next we will see the efficiency of A. A can fill 24 units in 6 hours. So in 1 hour how much it will fill? 24 by 6, which is equal to 4 unit per hour. So B can fill 24 units in 8 hours. So in 1 hour how much it will fill? 24 divided by 8, which is equal to 3 units in 1 hour. Then C can fill 24 units in 12 hours. Sorry, C can empty 24 units in 12 hours. So in 1 hour how much it can empty? So 24 divided by 12, which is equal to 2 units per hour it will empty. Okay. Now if we have to calculate the time at which all three will fill the tank. So to find that, first let us start with the last time, that is 9 am. Okay. So till 9 am, okay, till 9 am what all work is done by A and B. Okay, we will see that. Till 9 am A has filled how much tank? It will fill 4 units in 1 hour. 4 units in 1 hour. So till 9 am it has worked for 2 hours, isn't it? It has worked for 2 hours till 9 am. So therefore till 9 am how much it has filled? 4 into 2, which is equal to 8 units. Okay, till 9 am A has filled 8 units. Next, till 9 am B has worked how much? B can fill 3 units per hour. Till 9 am it has worked for 1 hour. So therefore how much it has filled in 1 hour? 3 into 1, which is equal to 3 units. Okay. So till 9 am A and B together they have filled how much? 8 plus 3, which is equal to 11 units. Okay. So what is the remaining time, remaining capacity? How much is remaining to be filled? If 24 is the total capacity, 11 is already filled by A and B till 9 o'clock. So 24 minus 11 is equal to 13 units. So now 13 units is remaining. Okay. Then after 9 am all three are working. A, B and C all are open, because at 9 am C is also opened. So till 9 am what all is done? First we will see the resulting thing, what will happen. A can fill 4 units, B can fill 3 units, but C will empty 2 units in 1 hour. So totally what is happening in 1 hour? 7 minus 2, that is 5 units is filled. Okay, 5 units is filled in 1 hour when all three are opened. Okay, now 13 units is remaining. So to fill 13 units, how much time will be taken? Okay, to fill 13 units when all three are open, running now. So 13 divided by 5, which is equal to 3 by 5 hours, which is equal to 2 hours. 3 by 5 is 36 minutes. Just now we had seen in the previous problem. So 2 hours 36 minutes. Okay. So to fill the remaining 13 units, all three will take, when all three are operating together, it will take 2 hours 36 minutes. So that means all three are opened at 9 am. At 9 am all three are started, isn't it? So 9 am plus this 2 hours 36 minutes. So how much it will give? 9 plus 2 is 11 and this 36 minutes. So 11:36. So at 11:36 the tank will be filled. So option C is the answer.